Okay, so we're beginning the law of sines, which is a little bit of a tricky topic. It's definitely going to be a bit long to explain, so just do your best and follow through. Now, the law of sines is really cool because the law of sines will help us relate the different sides and angles of a triangle a little bit better than just normal trig. So if I have this triangle here, so we'll call this triangle A, B, C. Remember that in a triangle, capital letters represent angles and lowercase letters represent sides. So this would be side A because it's opposite of angle A. If this is angle B, then side B is opposite that. And here's C, angle C, opposite side C. The law of sines says that if I have the ratios of these angles to their sides, or these sides to the sines of the angles, they will all be equal. So that means that A is equal to the sine of angle A is equal to B over the sine of angle B is equal to C over the sine of angle C. This is the law of sines. So we can solve for any of these variables given 3. So for example, I have these triangles here, and notice I'm given 3 sides, but I want to find this angle C. Well, because I'm given angle A, I can say that side A over sine of A is equal to side C over sine of C. And then I just plug in and solve. So this is 33 over the sine of 127 degrees is equal to side C, which is 10, over the sine of C. And that sine is what I'm looking for. So it's probably best to just get a decimal approximation over here. So I'm going to be using my calculator. Now, because I'm dealing with degrees, I want to first make sure that my calculator mode is in degree mode. All right, there it is. It's in degree mode. And then I'm going to get this left-hand side. So I'm going to do 33 divided by the sine of 127. And that's this decimal here. So 41.32. So I'll move this out of there. So 41.32 is equal to 10 over the sine of C. So don't forget, what I can say is, well, the sine of C is equal to 10 over 41.32. We can switch these two because we're multiplying both sides by sine of C and dividing by 41.32. So then to find C, I need to get rid of this sign. And the only way to do that is to take the inverse sign. So I'm going to take the inverse sign of 10 over 41.32. Now, because I rounded that, it's going to be a little bit off. So what I recommend is to type this in your calculator as inverse sine of 10 divided by, if you go to second negative sign, you get this answer. So it brings in this exact value. So inverse sine of 10. And so it's about 14 degrees. So some decimals there, but I'm going to round that off. And I'm going to say that C is about equal to 14 degrees. And that's my answer. All right, the next one here, we want to find the side AC. Well, this side is opposite of angle B, so that's really side B. So we want to do B over sine of B. I'm given both sides and angles. Oh, actually, no, I'm not. I'm not given angle C, so even though I have side C, I don't want to use that fraction. So I'm going to do the A. So I'm going to do A over sine of A. When you set up your equation, you want only one empty variable. In this case, it's going to be B. So I get sine 84 is equal to 21 over sine of 72. Now this is nice because b is in the numerator, so I can multiply both sides by sine of 84, so I get 21 over sine of 72 times sine of 84. And that's nice because I could just put that all into the calculator. So I get 21 divided by the sine of 72. Get some decimal, and then I can multiply that by the sine of 84. And there we go. We get 21.96 about. So B, so side AC is equal to B, which is about equal to 21.96. So that is my answer. Simple enough. So here are some more examples, which I don't think I have written notes for. No, so I'll just go through these. So law of sines will work with any variable. So here we have Q. So if we're finding angle Q, we're going to do side Q over sine of Q is equal to, because I have both r's here, I'm going to do r over sine of r. So we get Q, which is 10 over sine of Q is equal to r, which is 28 over sine of 125. So then I'm going to continue this up here. And I'm going to say, well, I'll do the rest of my calculator. So what I can do is do this value here. So 28 divided by sine of 125 gives me this. And then don't forget, because this sine of Q is in the denominator, I can switch this value with the sine of Q. So then I get 10 divided by my answer. And that's sine of Q equals this. So I'm going to take the inverse sine of that value to get about 17.01. So I'm going to write that Q is about equal to 17.01 degrees. For K, I'm going to say, since I'm looking for angle K, I'm going to say side K over the sine of K. Here, because I have angle H, I'm going to do the sine of H and the side of H. So the side of K, right here, is 12. So I get 12 over the sine of K, yet again in the denominator, over H, which is 35, over the sine, 94. And I'm just going to use this in my calculator again, so I'm going to do that same procedure. So I'm going to do 35 divided by the sine of 94. And then I'm going to do 12 divided by that value. And then I'm going to take the inverse sine of that. So inverse sine of my answer gives me about 20. So I'm going to say that K is about equal to 20 degrees. All right, here AB, so side AB is opposite of angle C, so I'm looking for C. So this is going to be C over the sine of C is equal to, because I have both angle B and side B, I'm going to use that, B over sine of B. So side C is what I'm looking for, over the sine of 22 degrees is equal to B, which is 26, over the sine of 24. So this is nice because I can just multiply those values. So 26 divided by the sine of 24 is this. And then all I have to do is multiply this by the sine of 22 to get c by itself. So I get 23.95. So down here, I get side c is about equal to 23.95. And then over here, AB, again, that's going to be side C. So because I have angle A, I'm going to say A over sine of A is equal to C over sine of C. So A is 32, so I get 32 over sine of 89. And that's going to be equal to C over the sine of angle C, which is 65. And again, I could use my calculator to do the rest. So 32 divided by sine of 89, and then times sine of 65, gives me about 29. So 29 would be about equal to C. So C is about equal to 29. Okay. I don't like that circle job, so oops. C is about equal to 29.0. Okay. This is great, however, there's something called the ambiguous case, so side-side angle. So if I'm given two sides and then an angle, there could actually be different cases. I could either have, so there could be either no triangles, so 0 possible triangles, exactly one triangle, or two triangles. And so this is dependent on what's there. So I could have either this obtuse triangle, or I could have this acute triangle. And notice, poor drawing here, if I have two sides and then an angle, so two sides and say this angle there, like that side-side angle, those could be the same, but these are two completely different triangles. And so we need to watch out for that. Now the textbook goes through this great procedure for rules and all this stuff. We don't need to do that. So here's an example. I have one angle, two sides. This is side-side A, side-side angle. What we're going to do is we're going to basically treat this like it's not an issue. So first thing, if I have two sides, one angle, I'm going to find that last angle. So I'm going to say that I'm going to have here side A over sine of A is equal to side B over sine of B. So this is going to be 16.8 over the sine of 22 is equal to 22.42 over the sine of angle B. So using that calculator again, I'm going to say 16.8 divided by the sine of 22. That's this value, and then so I'm going to do 22.42 divided by that. And then that's the sine of B, so if I take the inverse sine of that value, I will get the angle B. So 29.99. So I would say B is about equal to 29.99 degrees. Okay, so that's what angle B is. Now if I have two angles here, I could find the third angle. So if I have three sides, so A, B, and C, I also have three angles, A, B, and C. What I'm going to do is I'm going to assume that there are two triangles. So triangle. This would be triangle 1, and this would be triangle 2. So A, B, C, A, B, C. Okay, let's erase this. All right, so I'm given that A is 16.8, B is 22.42. I know that angle A is 22, and I just found that angle B is 29.99. All right. So what could angle C be? Well, if I do 22 plus 29.99, I get this. If I do 180 minus that value, I get 28.01. So that's my first angle, right? I know that this could be 28.01. So C would be 128.01. Okay, actually, so I made a little bit of a mistake here. So in this second triangle, then what we wouldn't want to do is find a coterminal angle. So I would do 180 minus 29.99. And that would get 150.01. So I'm going to put this here, 150.01. And so that is 180 minus 29.99. Now, could this be a triangle? Well, if I do that value plus the angle I already have, 22, I get this. That is less than 180, so that means that angle C would be 7.99 degrees. So notice here, in triangle 1, what I did was everything as usual, and I said, all right, so I did law of sines to get angle B, and then 3 angles add up to 180 degrees. So what I can do is add the sum of the 2 angles I have, and then subtract from 180, and that's angle C. However, because this is side-side angle, I could have 2 triangles. And so when I get my answer for B, what I do is I find a coterminal angle. So not necessarily a coterminal angle, a supplementary angle, I should say. So an angle that's supplementary to this would be 180 minus 29.99. And I get 150.01. So these 2 angles A and B are less than 180. So I can subtract 180 from the sum of these 2, and I get this. So there are 2 triangles that add up to 180 degrees for their angles. So that means that there are 2 triangles in this case. And then so to find the side for triangle, the missing side for triangle 1, I can do law of sines. So I can do A over sine of A is equal to, whoops, I don't know why I keep doing that. It's equal to B over the sine of B. So this is 16.8 over the sine of, sine of 22 is equal to, all right, I'm making all sorts of mistakes here. I don't want to do B. I already know the B values. I want to do C. So C over sine of C. So this is going to be 128.01 over the sine of C. Sorry, wrong yet again. I want to do side C over the sine of 128.01. Unfortunately, C and lowercase c and uppercase c look too much alike. All right, so I'm going to do 16.8 divided by sine of 22, and I'm going to multiply that by the sine of 128.01. And I get this value, 35.34. So we get that C is about equal to 35.34. So that's what we could have here, 35.34. Now, in our second triangle, what would that side be? Well, we could say is A over sine of A is equal to C over sine of C. So yet again, we have 16.8 over sine of 22 is equal to C over this time sine of 7.99. So I do that same 16.8 divided by the sine of 22. I multiply that by the sine of 7.99, and I get C, in this case, would be 6.23. So two different triangles work out for this. So again, to recap, if I see I have side-side angle, and you can draw a picture to help you if you need to, I set up law of sines as usual, find that second angle. So now I have two sides, two angles. But what I also do is I find a supplementary angle to this and say, all right, so triangle 1 could be 29.99 or 150.01. And then I find C by subtracting those angles from 180. If I get a triangle that works, I have two triangles, and I turn this into two different problems. Now, it could be the case where it doesn't work. Like, let's say angle B here were 70 degrees. Then this supplementary angle would be way too big, and I wouldn't have an angle here. This wouldn't work out. Or I could have zero triangles. Maybe this doesn't work. So you have to be careful with this. Here, just going through this. So here are just some examples. I've already worked these out. So here's side-side angle. So I see I have these two sides in the angle. So what I do is I set up the proportion first. Now if I go through and solve this, I eventually get here. Sine of B is about equal to 7.956. Great, but when I take the inverse sine of that, you can't do it. Remember when we did inverse trig functions? This is outside of the domain. So the angle's undefined. Well, there's nothing mathematically wrong with this. It's just that we get zero triangles, and that is possible. Here's another example. So side-side angle again. So what I do first is, because I know angle A, and side B, I'm going to find angle B first. So I set that up, solve all the way down here, and I get that angle B is 35.9 degrees. Fantastic. Now, what I do is find angle C, and so angle C I get to be 95.1 degrees. So here, I don't work this out, but angle B could be this, or it could be 180 minus 35.9. And so if we do that, it's 180 minus 35.9. I get this, 144.1. Huge. So that means that B equals 144. That's a 4. 144.1 degrees. However, I already know that A is 49 degrees. So the two of them together is greater than 180 degrees. So this can't be a triangle. And then there's only one. So then I just continue on as normal. Find angles, find side C after I find this. So to recap, law of sines is nice, straightforward, 3 fractions. But if I have a side-side angle, this ambiguous case, I could have 0 triangles, 1 triangle, or 2 triangles. So what we do is we first find the second angle. Once we find that angle, we find an angle that's supplementary to it. So once I get that, I see, could I make a second triangle? If yes, then there are 2 triangles. Like this last example, if I did that, I wouldn't have a second triangle. The 2 angles themselves would be greater than 180 degrees, so there's no possibility for that third angle to make a triangle. So that's where I only have 1 triangle. Or I could honestly set this up, get undefined for that second angle, and then it would be 0 triangles, no possible triangles. So that's law of sines. Law of sines itself is pretty simple, but it's the ambiguous case that you have to watch out for. So if you know you have side-side angle, be prepared to do a little bit extra work and thinking.